All right, we're going to be looking at 30, 60, 90 triangles here. So the basic thing you have to understand to open with is this. Okay, if we have just a generic 30, 60, 90, what will happen if this side over here is 1, then you double it, the hypotenuse will be 2, and then the side across from 60 will be root 3. Okay? So what's going to happen here, the side across from 30 is always the short side. Okay? And then the side across from 90 is always hypotenuse, and the side across from 60 is the long side. Whatever your short side is, that's what you start with. You double it to make the hypotenuse, multiply it by root 3 to make the long side, or the side across from 60. Don't think about this in terms of top, bottom, left, right, because as the triangle rotates, what you do to keep track of what belongs where is look at what's across from what. The side across from 30 is always the long side. Side across from 90 is always hypotenuse and needs to be doubled. Side across from 60 is always the long side and needs to be multiplied by root 3. So I think there's a way I have normally gone about doing this, but I think the easiest way to approach this is do this. Let's call the short side x. Let's call the long side because, the hypotenuse, because it gets doubled, we'll call it 2x. And let's call the long side across from 60 x times root 3. Okay, so we'll start with that, and everything we do we'll compare to that. Okay, so if I'm going to do a question like this, if I'm going to do okay, so if it just tells me that's 60 degrees, and it tells me this right here is 8. And let's say we want to find E. Okay, so let's say we want to find E. We know that that's 60, and we know that that's 8. So what we're going to do, notice this is harder because, well, I say it's harder. It's just you could easily get mixed up because, look, 60 is right here. Okay, so that would mean the 30 belongs right here. Okay, so if we were going to do this and we wanted to figure out what belongs where, in this case, you notice 30 is across from 30 is the 8. Notice across from 30 we call that x. Okay, so in this case we're going to say, what does x equal? Well, it equals 8. Okay, so this is going to make it easier. So then let's figure out what E is. And E is across from 90. It's the hypotenuse. So E is supposed to be 2x. And we already established that x equals 8. So let's solve. Plug in 8 for x. So E equals 16. Okay, some of you will get to a point where you see this, oh, short side is 8, you double it to make hypotenuse is 16. No problem. Here's where this could get a little bit harder, so I'll just make up a problem right here. I think where this could get hardest would be if they give you the long side, and then what they give you for the long side has nothing to do with the square root of 3. So let's just say they give us this, and the long side is just 17. So what we're going to do is we're going to look at this, and we're going to say, okay, the long side is 17, and on our basic one across from 60, the long side is x times root 3. So x times root 3 equals 17 in this case. So let's go ahead and get x alone, and we need to divide by root 3. So that's where we'll be. So we would like to say x in this case is 17 root 3. The issue is that 17 root 3 is not a good answer. The reason being is you cannot have a square root on the bottom. You need to get that out of there. A basic principle. This should be stuff, to be honest, and this isn't to make you feel bad, but by the time you learn this, and by the time you're using this stuff in geometry or trigonometry, wherever you're using it, what I'm about to do should be extremely comfortable to you, but a lot of times for people it's not. So I'll take the time to go over it real quick. You cannot have a square root on bottom. A basic, just a way that things work here. Let me take a generic example. What's the square root of 9 times square root of 9? Well, square root of 9 is 3. And square root of 9 is 3. And 3 times 3 equals 9. So the square root of 9 times square root of 9 is just 9. Notice what happens? Root times root just cancels out the root. So, because it works like that for every number, if we want to get rid of square root of 3, multiply it by the square root of 3. But if you do it on bottom, you also have to do it on top. So we already established root times root will cancel itself out, so you'll have 3 on bottom. And then as you just multiply across the top, you'll have 17 root 3. So in this case, x equals 17 root 3. Okay? So if you solve for x, x is 17 root 3. So notice 30 is just x. So 30 over here is x. And what is x? Well, we solve for x is 17 root 3. So 30 is across from 30. The short side is 17 root 3 over 3. Okay, and then what's across from the 90? Well, across from 90 is always 2x. And we decided that x is 17 root 3 over 3, so it'll be 2 times 17 root 3 over 3. So let's go ahead and do that real quick. Okay, so then we do 2 times 17. And we get 34 root 3 over 3. So then the hypotenuse here is 34 root 3 over 3. So this is how you're supposed to be able to use this relationship and apply it to every problem. There's 3 ways to go about doing this. And when I personally was in high school, I actually didn't use this method. But I feel like this method is the easiest to teach. It's the easiest to understand. So that's why I'm starting off teaching this method. So just take it, set up this, take whatever they give you, and set whatever they give you equal to the version that you get on the generic 30, 60, 90 and solve for x. Then use that x, you can plug it back into each one of these and find all the missing sides. Okay, hopefully you find this helpful.